Hi students, today I am going to deal with the topic polarimeter from the chapter Analyzers. Polarimeter from the chapter Analyzers. Upon completion of this presentation, you will be able to understand the concepts of polarization, principle of polarimeter, types of polarimeter, components of polarimeter, construction and working of polarimeter and applications of polarimeter. Upon completion of this presentation, you will be able to understand the concepts of polarization, the principle of polarimeter, types of polarimeter, components of polarimeter, construction and working of polarimeter and applications of polarimeter. Polarization. What is polarization? Polarization is defined as a phenomena caused due to the wave nature of electromagnetic radiation. It is a phenomena which is caused due to the wave nature of electromagnetic radiation. Sunlight travels through vacuum to reach the earth, which is an example of electromagnetic radiation or electromagnetic wave. These waves are called, which are emitted by the sun, are called electromagnetic waves. The waves that are emitted by the sunlight are called electromagnetic waves because they form when an electric field interacts with a magnetic field. These electromagnetic waves are formed when an electric field interacts with a magnetic field. There are two types of waves in nature, transverse waves and longitudinal waves. Transverse waves and longitudinal waves. What are transverse waves? Transverse waves are waves where the movement of the particles in the wave is perpendicular to the direction of the motion of the wave. Where the movement of the particles in the wave are perpendicular to the direction of motion of the wave. For example, the ripples when you throw a stone in the water, when you observe the ripples, when you throw a stone in the water, you can say they are transverse waves, where the movement of the particles in the wave is perpendicular to the direction of propagation of the wave. Perpendicular to the direction of propagation of the wave. Then the second type of waves are called longitudinal waves. Longitudinal waves are waves where the particles of the medium travel in the direction of propagation of the wave, in the direction of motion of the wave. They are called longitudinal waves. Examples of longitudinal waves are sound waves that travel through air. The sound waves that travel, the particles in the media travel in a direction of the propagation of the wave. Those waves are called longitudinal waves. Light is the interaction of electric and magnetic fields traveling through space. Light waves are electromagnetic in nature. They are formed by interaction of electric field with the magnetic field. The electric and magnetic vibrations of the light wave occur perpendicular to each other. The electric field moves in one direction and magnetic field is in another direction, always perpendicular to the electric field. So we have one plane occupied by the electric field, the magnetic field perpendicular to it, and the direction of the travel will be in perpendicular to both the electric field and magnetic field. So light is interaction of electric and magnetic fields traveling through space. The electric and magnetic vibrations of a light wave occur perpendicular to each other. The electric field will move in one direction and the magnetic field will always move in another direction perpendicular to the electric field. So we have one plane occupied by the electric field, the other by the magnetic field, and in perpendicular to these two planes we have the propagation of the wave. These electric and magnetic vibrations can occur in numerous planes. It can occur in numerous planes, any direction. If you change the direction of electric field, magnetic field will be moving perpendicular to that direction. And the propagation of the wave will be perpendicular to all the two, both the two fields. So what is these electromagnetic waves which are generated? What is the nature of these waves? What is the nature of these waves? A light wave that is vibrating in more than one plane is known as unpolarized light. We have two types of light. Light can be classified as polarized and unpolarized. What is unpolarized light? What is polarized light? Based on that principle only, the principle polarimeter works. Polarimeter works on the principle of polarized light and unpolarized light. You should know what is polarized light and what is unpolarized light. A light wave that is vibrating in more than one plane is known as unpolarized light. The light emitted by the sun or by a lamp or by a tube light or a lamp in a classroom or by a candle flame, all these types of lights are unpolarized light. That means the light wave that is vibrating in more than one plane. It's not a single plane but more than one plane. It is said to be unpolarized light. Such light waves are created by electric charges that vibrate in a variety of directions, thus creating an electromagnetic wave that vibrates in a variety of directions. Okay? So, a light wave that is vibrating in more than one plane is known as unpolarized light, as you can see in the figure. See the first figure, it is unpolarized light. It is traveling in different directions. The light emitted by the sun or by a lamp or by a tube light in a classroom, all are unpolarized light, or by a candle flame, it is an unpolarized light. Such light waves are created by electric charges. These light waves are created by electric charges that vibrate in a variety of directions. Thus creating an electromagnetic wave that vibrates in a variety of directions. So you have seen in the figure, you can see the polarized light. Now we have studied about unpolarized light. What is polarized light? It is possible to transform the unpolarized light into polarized light. How is it possible? How is it possible to transform the unpolarized light? What is unpolarized light? The light emitted by the sun or by the flame of a candle or by the lamp in a classroom, all these are called unpolarized light. The light wave is vibrating in more than one plane. They are said to be unpolarized. Such waves are created by electric charges that vibrate in a variety of directions, thus creating an electromagnetic wave which vibrates in various directions, variety of directions. So, such type of unpolarized light can be made polarized. Polarized light waves are light waves in which the vibrations occur in a single plane. Till now we have seen multi-direction, multi-planes. Now these vibrations occur only in a single plane. They occur only in a single plane. The process of transforming unpolarized light into polarized light is called polarization. So the concept of polarization, have you understood? The polarization is the process of transforming the unpolarized light into a polarized light is known as polarization. This is possible by a Polaroid filter. We are going to use a special type of filter called Polaroid filter. When unpolarized light is passed through this filter, Polaroid filter, it will convert that unpolarized light into a polarized light. A polarized light is nothing but a light wave in which the vibrations occur in a single plane. They occur in a single plane. So how can you do this polarization? Polarization can be carried out by using a Polaroid filter. Polaroid filter. The most common, there are several other methods, but this is the most common method. The most common method of polarization involves the use of a Polaroid filter. Polaroid filters are made up of a special material that is capable of blocking one of the two planes of the vibration of an electromagnetic wave. So it is made up of special material. The Polaroid filter is made up of a special material which is capable of blocking one of the two planes. We have two planes, one for the electric and other for the magnetic field, and both together are in perpendicular, and the wave propagation is perpendicular to both these fields. So, in Polaroid filters are made of a special material that is capable of blocking one of the two planes of the vibration of an electromagnetic wave. In this sense, a Polaroid serves as a device. So, it acts as a device that filters out one half of the vibrations upon transmission of the light through the filter. When unpolarized light is transmitted through the Polaroid filter, it emerges with one half the intensity and with vibrations in a single plane. It emerges as a polarized light. This is the principle of a Polaroid filter. So it is made up of a special filter which is capable of blocking, or it is what does it do? It filters out one half of the vibrations upon transmission of the light through the filter. This transmitted light that is coming out, emerging out from the filter, is called as polarized light, where one half the intensity and the vibrations are emerges with one half of the intensity and the vibrations in a single plane. So based on these concepts of polarization, and you have understood about polarized and unpolarized light, the concept of polarimetry comes into the picture. So what is polarimeter? The term polarimetry may be referred as the study of the rotation of polarized light by transparent optical active substance. So there are so many terms used here. In polarimetry, it is nothing but study of rotation of polarized light. We have studied what is a polarized light. Polarized light, what is a polarized light? Polarized light is nothing but when the unpolarized light is transformed into polarized light by using a Polaroid filter, we get a polarized light. That means that polarized light waves are light waves in which the vibrations occur in a single plane. So you are getting the polarized light. So it is the study of rotation of this polarized light by what? By a transparent optical active substance, which I am going to discuss with you in the forthcoming classes. Okay. So the rotation of the polarized light by transparent optical active substance, that study is referred to as polarimetry. This is a type of qualitative and quantitative analytical technique, as both identification and estimation of the compound can be done. Okay, it is this polarimetry, it is nothing but study of the rotation of the polarized light by an transparent optically active substance. What is this transparent optically active substance? I will discuss with you. This is a type of this polarimetry. It is a type of qualitative and quantitative analytical technique, as both identification and estimation of the compound can be done. This is a type of qualitative and quantitative analytical technique, as both identification and estimation of the compound can be done. The principle of polarimeter. What is the principle? The polarimeter instrument measures the rotation of the polarized light as it passes through an optically active substance, and the tendency of the molecules to rotate the plane polarized light towards clockwise or anti-clockwise direction, whose extent of rotation can be measured. You are going to take an optically active substance. Okay? And when light is passed through the meter, the rotation of the polarized light as it passes through an optically active substance, the tendency of the molecules to rotate the plane polarized light towards clockwise or anti-clockwise direction, whose extent of rotation can be measured. These compounds are called as optically active compounds. So the compounds through which when polarized light is passed through the optically active compounds, they have the tendency of the molecules to rotate the plane polarized line. So by measuring the angle of rotation, we can identify the compound, we can identify the substance. So there is one more factor called optical activity, which is unique characteristic of a molecule. Each molecule has its own optical activity. So what is this optical activity also? I'll be telling you. So the instrument which is used to measure the rotation of the polarized light as it passes through an optically active substance, and the tendency of the molecules to rotate the plane polarized light towards clockwise or anti-clockwise direction, whose extents of rotation can be measured. This is a principle of polarimeter. These compounds are called as optically active substances or compounds. There is these compounds, each compound has its own unique characteristic. It is that characteristic is called optical activity. Optical activity. So what is optical activity? Optical activity is the ability of a chiral molecule. It is the ability of a chiral molecule. What is a chiral molecule? It is a pair of molecules that are mirror images of each other. They are the mirror images like benzene. They are the mirror images of each other. So optical activity is the ability of a chiral molecule to rotate the plane of the plane polarized light measured using a polarimeter. So it is the optical activity, it is a characteristic of a molecule. It is the ability of the chiral molecule to rotate the plane of what? Plane of the plane polarized light measured using a polarimeter. A simple polarimeter consists of a light source, a polarizing lens, sample tube and analyzing lens. These are the common components of a simple polarimeter. What does it consist of? It consists of a light source. You can see in the figure, you have a light source, then a polarizing lens or the filter it is called. Then we have the sample tube where the sample is placed, and the analyzing lens. So when light passes through the sample that can rotate plane polarized light, the light appears to dim because it no longer passes straight through the polarizing filters. When there is no sample present inside the sample tube, what happens? The light falls on the polarizer. Directly after passing through the vacuum, it goes on to the analyzing lens. So there is no variation in the intensity of the radiation falling on the analyzer. So you don't find the difference. But if you are placing a sample inside the sample tube, when light passes through the sample that can rotate, what does the sample? It is an optically, as I told you, a special type of sample is used. What is that sample? It is an optically active sample. So that sample, it has the property of rotating the plane polarized light that is passing through it by an angle. The light appears, when it is rotating, what happens? The light appears dim because it no longer passes straight through the polarizing filters. The amount of rotation is quantified as a number of degrees that the analyzing lens must be rotated so that it appears as if no dimming of the light has occurred. So what you're going to do? Now you're sending the polarized light into the sample. The sample tube contains the sample. So what happens? The polarized light is deviated. It is rotated by an angle. So thereby causing dimming of the light reaching the analyzer. So what you're going to adjust the analyzer such that you're going to rotate the analyzer such that the dimness is reduced or it disappeared. So by measuring the angle of rotation, you can identify the sample. You can identify the composition or concentration of the sample, or you can identify the compound present in the sample. So measuring the optical activity. When rotation is quantified using a polarimeter, it is known as observed rotation. Now you are quantifying your process. You are measuring something. You are measuring the angle of rotation. So known as observed rotation, because rotation is affected by the path length and constant. There are two parameters which affect the rotation. It depends on the path length. That is the time taken for the light to travel through the sample. And it depends on the concentration of the sample. That means how much the sample is present, that will rotate the light. When these effects are eliminated, a standard for comparison of all the molecules is obtained, and that rotation is called specific rotation alpha. Alpha is equal to 100 alpha by CL, when concentration is expressed as gram sample per 100 ml solution. So this is how you're measuring the measuring optical activity. You're measuring the optical activity. Enantiomers are nothing but chiral molecules. Chiral molecules are nothing but they are mirror images of one another. These enantiomers will rotate the plane of the polarization in exactly equal amounts. Same magnitude, but in opposite direction. We are going to use these type of substances, optically sensitive, optically active substances. Okay, they produce equal angles but in opposite directions. Dextrorotatory is designated as small d or plus, that is clockwise rotation. To the when the rotation of the analyzer is towards the right, then it is called dextrorotatory and it is designated as small d and it is positive. When it is rotated in the anti-clockwise direction, when the analyzer is rotated in the anti-clockwise direction, that rotation is called levorotatory. First one is dextrorotatory and second one is levorotatory. In the levorotatory, it will be represented by small l and it is minus, negative. That means towards the left side, anti-clockwise direction. If only one enantiomer is present in the sample, it is considered to be optically pure. Your substance is optically pure if you have only one enantiomer. When a sample consists of mixture of enantiomers, the effect of each enantiomer cancels out molecule for molecule. So you are going to find the optical activity of the, you are going to measure the optical activity of the sample present. Measure the optical activity of the sample. So this is about your optical activity, which depends upon the nature of the molecules. It is a unique characteristic of molecule. Each molecule has its own optical activity. So what is this? Is the diagram. This is the figure or the instrument that is used for measurement of optical activity. Okay, so polarimeter as an instrument is a scientific instrument which is used to measure the angle of rotation caused by passing polarized light through an optically active substance. This is the figure of the instrument, polarimeter. This is the figure of the instrument polarimeter. It is a scientific instrument which is used to, what you are going to measure? You are going to measure the angle of rotation caused by passing polarized light through an optically active substance. So this is the figure of your polarimeter, So inside the polarimeter, the construction is as shown in the figure. What is the polarimeter? It consists of a light source. Then we have two, one is a polarizer and an analyzer. Two polarizers are used. One acts as a polarizer, fixed polarizer, which cannot be rotated. You have the, from the light source, what you are getting? You are getting unpolarized light. It is moving in different directions. This unpolarized light, when it is made to fall on the fixed polarizer, which cannot be rotated, you get polarized light, and that polarized light is passed through the polarimetry tube. The tube is about 10 centimeters long. So the polarimeter tube contains an optically active substance such as an amino acid in a solution, which causes the plane of the polarized light to rotate. It causes the plane of the polarized light to rotate. Notice you have an analyzer. After the sample tube, you have an analyzer. The analyzer is rotatable polarizer. This lens is rotated until no light goes through the second lens. The angle is then measured to determine the optical rotation of amino acid solution. What is happening? Because of the optical activity of the substance placed in the sample tube, this polarized light is being rotated by an angle. So you are adjusting the analyzer knob, you are rotating the knob such that no light, such that the dimness of the light, of the intensity of the light coming from the polarizer is resumed. Okay, it is resumed. So notice that the plane of the vibrating light has changed after going through the polarimetry tube. Then you have the eyepiece or the eye here. So the polarimetry tube contains an optically active substance such as an amino acid in a solution, which causes the plane of the polarized light to rotate. It can be rotated either in the clockwise or in the anti-clockwise direction. If it is in the clockwise direction, that type of rotation is called dextrorotatory activity, and the other type is called levorotatory activity. If towards the left it is anti-clockwise, towards the right it is called clockwise direction. Depending upon the direction, you can identify the sample. Then types of polarimeter. We have different types of polarimeters. Lorentz half-shade polarimeter, biquartz polarimeter, Lipich polarimeter, quartz wedge polarimeter, manual polarimeter, semi-automatic polarimeters, and automatic polarimeters. These are the different types of polarimeters which are used. Lorentz half-shade polarimeter, biquartz polarimeter, Lipich polarimeter, quartz wedge polarimeter, manual, semi-automatic and fully automatic type of polarimeters. This is the optical diagram of a polarimeter. It consists of a light source. The light source is emitting unpolarized light. This unpolarized light is made to fall in a polarizer which is not rotatable. Then the polarizer, what does it do? It converts the unpolarized light into polarized light. This polarized light is passed through the sample tube. The sample tube contains optically active substance, which is the sample that is to be tested. Because of the optical activity of the sample, the polarized light is rotated by an angle. So you are going to rotate the analyzer such that the intensity of the radiation coming out of the sample tube can be resumed back, can be resumed back. This is the working of your polarimeter. The components of a polarimeter. The polarimeter consists of the following basic parts: a light source, a polarizer, an analyzer, a graduated circle to measure the amount of rotation, and the sample tubes. So these are the basic components of a polarimeter: a light source, a polarizer, then we have the sample tube, then we have the graduated analyzer and the graduated circle to measure the amount of rotation, Coming into the description of the different components of a polarimeter, the light source. The most common light source for polarimeters are sodium vapor lamps and mercury vapor lamps. The most common light sources for polarimeter are sodium vapor lamps and mercury vapor lamps. Sodium vapor lamps emit 589.1 nanometers. Sodium vapor lamps emit 589.1 nanometers and mercury vapor lamps emit 579.1 nanometers. These are the most commonly used light sources in polarimetry. You are going to use either sodium vapor lamps or mercury vapor lamps. Then the polarizer or the analyzer, we have their working principle is both the same. The polarizer consists of a crystal, usually calcite or quartz, cut diagonally at such an angle that one component of the light is totally reflected. The second component passes through the second half of the crystal and thus emerges going in the same direction as the original beam. Then the polarizer or the analyzer, the two halves of the prism are cemented together. It consists of a crystal that is calcite or quartz. They are cemented together. The Glan-Thomson prism or the nickel prisms are commonly used prisms. Usually Nickel's prisms are used as polarizers or analyzers. Intensity of the light transmitted through the combination is given by I is equal to K into I naught into cos square theta. I is the intensity of the radiation that is passed through the polarizer and through the analyzer. So the intensity of the radiation is given by I is equal to K into I naught into cos square theta, where I is the emerging intensity from the analyzer, I naught is the incident intensity on the analyzer, theta is the angle between the direction of transmission of the two prisms, and the K is the constant of absorption and reflection. It is the constant of absorption and reflection. So this is the intensity relationship of the light transmitted through the combination of the analyzer and the polarizer. Then we have the graduated circle. A graduated circle is fitted with a linear with a vernier. A graduated circle is fitted with a vernier for precise measurement of the angle through which the analyzing prism can be rotated. So the analyzing prism is rotated. So you can measure the angle from the graduated circle. The sample tube. The polarimeter tube must be free from stain, otherwise it will produce circular polarizations of light. So polarizations are of two types, linear polarization and circular polarization. We are considering here linear polarization only. So this can be eliminated. Circular polarizations must be eliminated. So polarimetry tube must be free from stains. If there are stains, it undergoes circular polarization. Hence, each tube should be tested by filling it with water, placing between crossed prisms and noting whether dark fields remain dark. It should be free from stains to avoid circular polarization. Test it by filling it with pure water. You can test the sample tube by filling it with pure water. Working of the polarimeter. Light from the source is unpolarized. This means that each light wave oscillates randomly in spatial direction. Is made to fall on the polarizer. Okay, unpolarized light is from the source is falling on the polarizer. So the polarizer is a polarizing filter. It transmits only light in certain polarization directions and suppresses the light of other polarization direction. That is, it transforms or it converts unpolarized light into polarized light. Polarized light has only one specific plane. Okay, so when polarized light passes through the analyzer placed parallel to the polarizer, the plane of oscillation is maintained and light reaches the screen. If the analyzer is rotated by 90 degrees, it suppresses the polarized light beam and the screen behind it becomes dark. Okay, when there is no sample placed in between the polarizer and the analyzer. This is the case when no sample is there present in the sample tube. Okay, if it is rotated 90 degrees, you will get a on the screen it will appear dark. Okay, if then the working of the polarimeter when the sample is introduced. When we are introducing the sample into the sample tube, how does it work? If a sample tube with no optically active substance is placed between the polarizer and the analyzer, the oscillation plane is retained. How that oscillation plane is after the polarizer, the same thing will be after the analyzer also. So light will be visible on the screen at the other end. If the tube is filled with optically active substance, like a sugar solution, granulated sugar, a change becomes visible. You can observe a change. The operation of the optically active substance has the following effect. The light at the back of the screen becomes much less visible. It becomes dim. Why it becomes dim? Because as it passes through the optically active substance, your polarized light will be rotating off. It will rotate. This happens because the oscillation plane of the light has been changed. It has been changed. The reason is sugar solution as an optically active substance has rotated the polarization direction. It has rotated the direction of the polarized light. The angle of rotation depends on the length of the path in the solution. It depends on the length of the path in the solution and the concentration of the solution itself. And it is also depends on the type of the sugar. It depends on the type of the sugar. So this is how you can observe the figure. Measurement using polarimeter. If the sample tube is filled with granulated sugar like sucrose, the angle of rotation is dextro-rotatory. As I told you, the angle of rotation will be clockwise. It depends upon the type of the sugar also. If the sugar is a granulated sugar like sucrose, the angle of rotation is dextro-rotatory and it is clockwise direction. It is in the clockwise direction. If the tube is filled with pure fructose, the angle of rotation is levorotatory. If it is filled with pure fructose, the angle of rotation, it depends upon the nature of the sugar also. Sucrose, it rotates in the clockwise direction, and if it is fructose, it is rotating in the anti-clockwise direction, counterclockwise direction or levorotatory direction, and it is rotating in the left side. So this is the experimental setup of a polarimeter. So you have your sodium lamp here on the right side. The sodium lamp is emitting light of unpolarized light. When it falls on the polarizer, you have a polarizer as shown in the figure. The polarizer, it changes the polarized light into unpolarized light into polarized light. This polarized light is passed through the sample tube. The sample tube contains sugar solution, and when it is an optically active substance, so the rotation of the polarized light takes place, and that is observed in the analyzer. So by rotating the analyzer, you can rotate the analyzer such that that there is no light emerges, so that the analyzer is rotated such that you can observe the radiation. You can observe the polarized radiation by what angle it is rotated. So you can observe through the eyepiece present on the side. So this is the experimental setup of polarimeter, experimental setup. The operation panel is, the front panel appears like this. You have the 0 set, the rotating your dial. You can rotate it either right side or left side. When it is dextro rotatory, it is towards the right, that is clockwise direction, and when it is anti-clockwise direction, it is towards the left, and it is called levorotatory direction. So the results in the polarimeter: when the left semicircular field is brighter, when the left, you have two circles, two semicircles. This is one complete circle as shown in the figure. One side it is blank and other side is, so when the left side semicircle field is brighter, left hand rotating sample. Continuously press the left hand rotate switch and the translucent semi-fluid gradually changes as below. See, you can see it is changing gradually, it is changing to dark pattern. Okay, then the result when you're rotating towards the right. Previously it is towards the left, it is becoming dark, and now it is towards the right. That is when you are rotating the handle in the left hand side. When the left semicircle field is brighter, left semicircle field is left-handed rotating sample. Continuously press the left-hand rotated switch and the translucent semicircular fields gradually changes as below. It changes as below. This is how the polarimeter, through the eyepiece, when we observe, you can see this type of disc when it is rotated in the clockwise and anti-clockwise direction depending upon the sample present. If it is sucrose or if it is fructose or if it is any other material, whatever substance you are using, you will be observing a pattern like this where the dimness is changing. The intensity of the light radiation is changing. So this is the optical, this is the instrument, and these two, the lower tubes, are called the sample tubes. For different amounts of sample, you can use different types of tubes. This is the appearance of your polarimeter, how it appears, and in the field view through the eyepiece, you can observe the different patterns. Above or below optical zero, it appears in a dark patch in the middle. Then field at optical, when they are optically zero, you will have like that pattern as shown in the figure 2, and in figure 3, below or above optical zero. For the first one is above or below optical zero. The central one is dark and the remaining half circles, remaining sectors are bright. And when the field at optical zero, the central portion is dim. When the field at through the field view, you can observe the figure 3, below or above optical zero. Above optical zero. This is the field view of your polarimeter. Field view of your polarimeter. Then coming to the applications of polarimeter. Polarimeters are used for analysis of sugars, to analyze sucrose, for identification of optically active compounds, identification and determination of optically active compounds. They are used in chemical industry. Many chemicals exhibit a specific rotation as a unique property, like refractive index. In many cases the refractive index is the unique property of different chemicals, which can be used to distinguish it. They are used in chemical industries. Then another common thing is food and beverage industries and pharmaceutical industries make use of polarimeters, widely used in food and beverage and pharmaceutical industries, where the concentration of this and the purity of the samples are should be precisely measured. So concentration and purity measurements are done to those samples that display specific rotations that can be calculated for purity with a polarimeter. Includes like they are like steroids, diuretics, antibiotics, narcotics, vitamins, analgesics, amino acids, essential oils, polymers, starches, and sugars. So these are the different types of compounds or materials whose concentration and purity can be measured using polarimeter. Then in sugar industry, polarimeters are used in sugar industry for determining the quality of both juice from sugarcane and refined sucrose. Often the sugar refineries use a modified polarimeter with a flow cell called a scarimeter. Okay, modified with a flow cell called a scarimeter. The other applications of polarimeters are polarimetry of thin films and surfaces, commonly known as ellipsometry. You are going to measure the thin films and surfaces. Polarimetry is used in remote sensing applications such as planetary sciences and weather radars. They are used in remote sensing applications like planetary sciences and weather radars. Polarimetry can be used to measure various optical properties of materials, including linear Bayer fringes, also known as optical rotation or optical rotary dispersions. Dichroism, tarvata, then dichroism linear, dichroism circular, dichroism, and scattering. These are the different applications of polarimeters. Polarimeters are used in different applications. They are used in measuring the optical properties of various materials. Optical properties of various materials. So to summarize our topic of discussion today, we have understood the concept of polarization. So what is polarization? Polarization is a phenomena that is caused due to wave nature of electromagnetic radiation. When light rays, this is a phenomena which was observed, that is observed by the wave nature of electromagnetic radiation. Polarized and unpolarized light, we have two types of the process of transforming unpolarized light into polarized light is known as polarization. Okay, briefly we can say as the process of transforming unpolarized light into polarized light is called polarization. Then polarimeter. Polarimeter, it is an scientific instrument which is used to measure the angle of rotation caused by passing polarized light through an optically active substance. It is a scientific instrument which is used to measure the angle of rotation caused by passing polarized light through an optically active substance. We have the principle of polarimeter. It is nothing but a study of rotation of polarized light by transparent optical active substance. It is a type of qualitative and quantitative analytical technique, as both identification and estimation of the compound can be done using polarimeter. Then we have studied about the types of polarimeters: Lorentz half-shade polarimeter, biquartz polarimeter, Leipzig polarimeter, quartz wedge polarimeter, manual polarimeter, semi-automatic polarimeter, and fully automatic polarimeter. Then the polarimeter optical components of a polarimeter are the light source, the polarizer, the sample tube, the analyzer, and the graduated scale to measure the amount of rotation. The light source, most commonly used light sources are sodium vapor lamps which emit light at 589.1 nanometers and mercury vapor lamps which emit light at 579.1 nanometers. Then we have the polarizer. Polarizer consists of calcite or quartz crystal cut diagonally at such an angle that one component of the light is totally reflected. The second component passes through the second half of the crystal and thus emerges going in the same direction as the original wave. The intensity of the light transmitted through the combination of the prisms is given by I is equal to combination of the polarizer and the analyzer is given by I is equal to K into I naught into cos square theta, where I is the emerging intensity for the analyzer, I naught is the incident intensity on the analyzer, theta is the angle between the direction of the transmission of the two prisms, and K is the constant of absorption and reflection. Then we have the graduated scale. It is fitted with a linear for precise measurement of the angle through which the analyzing prism is rotated. The polarimeter tube consists of a optically sensitive active material. It is made up of this sample tube. It must be clean. It must be free from strains to avoid circular polarization. Then coming to the working, if the sample, coming to the working principle of the polarimeter, when light from the source which is unpolarized is passed through the polarizer transforms the light into a polarized light. When this polarized light is passed through the analyzer, the plane of the oscillation is maintained and light reaches the screen if there is no sample present in between the polarizer and the analyzer. If the analyzer is rotated by an angle 90 degrees, it suppresses the polarized light and the screen behind appears dark in color. If the sample with no optically active substance is placed between the polarizer and the analyzer, the oscillation plane is retained. Light will be visible on the screen at the other end. If the tube is filled with optically active substance, a solution of granulated sugar, a change becomes visible. The operation of the optically active substance has the following effects. The light at the back of the screen becomes much less visible. This happens because of the oscillation plane of the light that has been changed. Sugar solution as an optically active substance has rotated the polarized direction. The angle of rotation depends on the length of the path in the solution and on the concentration of the solution itself, and it is also depends on the type of the sugar solution. So different sugar solutions have different angle of rotation. If it is granulated sugar, the angle of rotation is dextro rotatory, that is in the clockwise direction. If it is fructose, the angle of rotation is levorotatory, it is in the anti-clockwise or counterclockwise direction. So the applications, coming to the applications of polarimeter, they are used for analysis of sugars, for analyzing sucrose, for identification and determination of optically active compounds. They are used in chemical industry, then in food and beverage industries and pharmaceutical industries to find out the concentration and purity of the samples used in food and beverage and pharmaceutical industries. Then they are used in sugar industries to determine the quality of both sugar from the sugar cane and refined sucrose. Polarimeter is used in thin film and surfaces, which is commonly known as ellipsometers. They are used in remote sensing applications such as planetary sciences and weather radars. Remote sensing applications, polarimeters are used, and they are used to measure various optical properties of materials. They are used to measure the various optical properties of the materials. So these are some of the applications of polarimeters. Polarimeters are used in food and pharmaceutical industries. Concentration and purity measurements are very important to determine the product or ingredient quality in food and beverage industries and pharmaceutical industries. Okay, this is very, very useful in pharmaceutical industries, and they are also one of the other important application area where they are used is they are used in remote sensing applications such as planetary science and weather radar, and they are used to measure the various optical properties of materials including linear Bayer fringes, circular Bayer fringes, then circular dichroism and scattering. So this is all about polarimeter.